Well, welcome to the first day of implicit differentiation. This happens to be one of my absolute favorite topics. Now again, it might look a little goofy at first. By the time we practice it for a few days, hopefully you'll be feeling pretty confident. Up until today, everything we've done so far has been an explicit equation. For example, most equations have said y equals, for example, 3x squared minus 5. This is explicitly solve for y. Or y equals 4x. Okay, we could easily get by y by itself. For the next few days, we're going to focus on implicit equations, where we can't get y by itself. For example, x squared plus 4y cubed plus 2y equals 10. This equation is pretty difficult, almost impossible to solve for y. I could subtract this x squared over and get 4y cubed plus 2y equals 10 minus x squared, but I can't exactly solve for y. I could factor a y out if I wanted, but I'd still have y left in here. So this is an implicit equation, when my equation cannot be solved for y. So in order to solve those equations, we're going to use implicit differentiation. We are differentiating with respect to x. So what that tells us, if there is only an x, just differentiate as usual, whether it's power rule, product rule, chain rule. However, if there's a y, we need to use implicit differentiation. So watch our notation here. This is saying take the derivative with respect to x. So let's mark that in our notebook. Right here is telling us derive, or take the derivative with respect to x. So basically, my goal is, do these variables match up? If they do, I'm just going to go about my normal business. The derivative of x cubed is simply 3x squared. And again, that's because these variables match. I'm taking the derivative with respect to x, and x is my variable. Now watch how the second one changes, b. I'm taking the derivative with respect to x, that's what this means down here, of y cubed. Do these variables match this time? The answer is no. I'm taking the derivative with respect to x, but I have a y in my problem. So this means I'm going to use implicit differentiation. Now, I'm going to derive, and it's going to look the same, but I'm going to add the chain rule in. So the derivative of y cubed is 3y squared. Okay, but now I have to take the derivative of y with respect to x. So I'm going to say times dy dx. So let me say that again. This is the power rule, so I get my 3y squared, and now I take the derivative of that inside term, so to speak, and the derivative of y is dy dx. Let's try another one. Take the derivative with respect to x of x plus 3y. So I'm just asking myself, do the variables match? Okay, here they match, so the derivative of x is just 1, nothing fancy. Here they don't match, so when I take the derivative of this, I'm going to have to add in that, or multiply by that dy dx. So the derivative of 3y is just 3, and then the derivative of my y is dy dx. So I get 1 plus 3 dy dx. Let's try another one. Take the derivative with respect to x of xy squared. Okay, so do your variables match? Well, this one does, but this one doesn't, so I'm going to use implicit. The other thing you need to say to yourself is, what does this say? Read it out loud like you would read it to a second grader. This says x times y squared. So I need to catch product rule there. So I'm going to say the first term, derivative of the second, which I'm going to leave blank for a moment, plus the second term, derivative of the first. I'm going to leave blank for a moment. And now I'll go back and take it. I need the derivative of the second term. So the derivative of y squared, just my power rule, 2y. Now because it's a y, dy dx. The derivative of my first term, x, was just 1. So as I neatly write this, I'm just going to put these together. I can multiply. I'm going to say that's 2xy dy dx plus y squared. Before we tackle our next big problem, let's write out the guidelines for implicit. Step 1. Differentiate both sides with respect to x. Step 2. Collect all dy dx on one side. Step 3. Factor out dy dx. And step 4. Solve for dy dx. We'll use these same 4 rules every time. Example 1. Find dy dx given y cubed plus y squared minus 5y minus x squared equals negative 4. So let's just follow our guidelines. Differentiate both sides with respect to x. Now remember, I'm doing it with respect to x, so if it doesn't have an x, we're going to put in that dy dx. So the derivative of y cubed is simply 3y squared. That doesn't match, so dy dx plus y squared is 2y. That didn't match, so dy dx. The derivative of negative 5y, well, the slope is negative 5. That y doesn't match, so dy dx. The derivative of x squared is going to be minus 2x. Now that matched with my x, so we leave that alone. Then I have an equal sign. And remember, differentiate both sides. The derivative of negative 4 is 0. So step 1 is done. Step 2, collect all the dy dx's on one side. So if it has a dy dx, I'm going to leave it on this side. If it doesn't, I'm going to boot it to the other side. This one stays, this one stays, this one stays, this one gets the boot. So I'm going to rewrite it quickly. 3y squared dy dx plus 2y dy dx minus 5 dy dx equals, I'm going to add that over, 2x. Step 3, factor out the dy dx. Now you'll notice I can pull that out as a GCF. So I'm pulling out dy dx, and I'm going to bracket in what I have left, 3y squared plus 2y minus 5. And that's equal to 2x. Lastly, step 4, solve for dy dx. I basically just need to get this by itself. Well, again, if I read it, it says dy dx times this junk. So all I'm going to do is divide that junk by both sides. That will simply cancel on the left side, and I'll divide it on this side. So my final answer is dy dx equals 2x over 3y squared plus 2y minus 5. And I'm done. So 4 easy steps. Example number 2. Find dy dx. So before you take the derivative, I can't stress reading it out loud to yourself. This says x squared, so that's just power rule. What does this say? X times y. Make sure you said times and use product rule there. Minus 4y, it's just a coefficient, equals 3x, that's just a coefficient. So I just want to be clear, I definitely have product rule around those two. Alright, so the derivative of x squared is just 2x plus, I love to bracket my product rule in just so I'm very clear on it. I'm going to say first, the derivative of y you might be thinking is 1, which is true, but then don't forget you need dy dx, plus the second, and the derivative of x is just 1, minus the derivative of 4y is just 4, but because it's a y, we need dy dx, equals the derivative of 3x is just 3. Okay, so I'm going to clean this up. I'm going to say that's 2x plus x dy dx plus y minus 4 dy dx equals 3. So I've done the calculus. Nothing left is calculus. This is just nice, easy algebra. Remember, collect the dy dx's on one side, boot anybody else to the other. So I'm going to leave this x dy dx and the minus 4 dy dx. Okay, now obviously I'm doing a little bit of this in my head. I'm subtracting the 2x over and I'm subtracting the y over. So I'm saying minus 2x and minus y. Then I'm going to factor out my dy dx. And I'm left with x minus 4 equals 3 minus 2x minus y. And then lastly, to get that dy dx by itself, I'm going to divide both sides by the x minus 4. So I'll write it out. I mean, again, you can probably do that in your head. So I'm just going to say 3 minus 2x minus y all over x minus 4. And there you have it. An implicit differentiation, or implicit derivative. Alright, I'm making this one a little uglier. I've got find dy dx of 4x cubed minus 3xy squared plus 2xy equals 1. Alright, so I'm stressing, read it out loud. 4x cubed. I didn't say times, that's just a coefficient. So this derivative is very simple. Hopefully you're saying 12x squared. Okay, now read the next term out loud. I have minus 3x y squared. Now I just want to stress, remember the product rule is between two variables. Let me say that again. The product rule is between two variables. So I'm going to bracket in this x and this y squared. That's who I'm doing product rule between. So what I like to do is leave the negative 3 and bracket in that product rule. And again, the product rule is only between the x and the y squared. So I'm saying first is x. The derivative of y squared is 2y dy dx plus, keep the second, y squared. The derivative of x is just 1. Notice this bracket. This is a huge deal. Okay? Plus, I have 2xy. Again, that's x times y. The product rule is between two variables. So what am I going to do with that 2? Well, I'm going to leave that plus 2 out front and bracket in my product rule. So I'm going first, the derivative of y is dy dx, plus the second times the derivative of the first equals the derivative of 1 is 0. If you got that part, you did the hard part. That's the calculus part. The rest is just cleaning her up. So now I'm going to say this is 12x squared, and I'm just going to nicely distribute this negative 3 through. Notice I'm distributing because of that plus sign. So I'm going to say that becomes negative 6xy dy dx minus 3y squared. And again, I have a plus sign in here, so I'm going to distribute this 2 through. So I'm going to get plus 2x dy dx plus 2y equals 0. And again, just some algebra. I'm going to leave anybody with a dy dx on one side and anybody else to the other side. So I'm going to say this is minus 6xy dy dx plus 2x dy dx equals, so this term, and this term, I'm booting over to the other side. So I'm going to subtract the 12x squared over. I'm going to add the 3y squared over. And I'm going to subtract the 2y over. Then I'll factor out that dy dx. So I've got negative 6xy plus 2x. And lastly, divide that junk over to get my dy dx by itself. Now, there's one important thing I have not mentioned yet. This may not be a choice. Okay, in my multiple choice section, even though this is the correct answer, it may not be a choice. And here's why. I could have, and I think you'll agree with this, if I wanted, could I have taken these dy dx's and brought them to the other side? I think you would agree with that. And then I could have factored them out on this side and divided that junk over. So basically, I would have had positive 12x squared minus 3y squared plus 2y divided by a negative 2x and a positive 6y. What I'm trying to say is there are two equivalent answers. So make sure you put this in your notebook. This is equivalent to the negated version of that. So I could have positive 12x squared minus 3y squared plus 2y all over positive 6xy minus 2x. And remember, those are equal, so just pay attention to the multiple choice. If you don't see your answer, negate every term and it's equivalent. And if you're still stuck with what I'm trying to say, Let's say you had a fraction 1/2, and you negate every term. -1 over -2. Would you agree that still turns out to be 1/2? Okay, so these are still the same thing if you negate every term. For our last example of the night, I want you to take this derivative in your notebook, and I'm going to check it tomorrow as a little quiz grade. So take your time, make sure you've paused and rewind when you need to, and we'll see you tomorrow. Have a great night.